Hello students, how are you all? I welcome you all to the class. Till date we have studied about motion in a plane and I have told you also about relative motion. In relative motion we have talked about the riverboat problem, the rainman problem, and we also discussed about graphical representation of certain variables like xt graph and vt graph, and then I showed some example how you can make other graphs using some given graph. And I know that you would have practiced problems and the understanding would be very simple in your mind, the concept would be very much clear with you all. Let's go today, let's not limit ourselves with only studying motion in a straight line. Today we'll start studying motion in a two-dimensional plane, that is in a two-dimensional space. That is, let us take an example. Suppose I have this chalk holder and if I throw it, it will come back. It was following a straight line path, it again came back along the same straight line path. So such is a motion in a straight line. Now suppose I throw the chalk making some angle with the horizontal, like say in this way. So this time it is not moving along the straight line, but there is some other kind of path, but certainly it's not a straight line path. So we can say this chalk holder moved along a two-dimensional direction, or let's say it moved in a plane. And suppose let us say a fly is flying in space. A fly will be flying in space, it will be moving along the three-dimensional space, or let's say all the three position coordinates will be varying with time. Generally how we can depict motion in two dimension, you can see here. Let me draw a graph representing the displacement along the vertical direction and along the horizontal direction. Along the horizontal direction we are mentioning by x, along the vertical direction I am mentioning by y. Let us say the trajectory, the path followed by the particle is somewhat like this. Let us say it is going along a path given by this way. That is, the y coordinate and x coordinate are related as per this curve. Now suppose at some time t, the particle is at this point A. Let us say at some time t1, the particle at this point A, its coordinates are given as x1, y1. After some time, that is at time t2, let us say the particle reached point B and its coordinates are given as x2, y2. Now this point, let us say this is x1, this will be x2, and similarly we can also mention about the y coordinates, that will be y1 here and that will be y2 here. This was all about, we can see the path is not a straight line, it's a different path but not a straight line. Now this is actually the trajectory. By trajectory we mean the path followed by the particle. Now let's say during some moment, at some instant of time, the particle is somewhere here. Let us say the particle is somewhere here, its coordinate is given as x, y, the general coordinate. Now the particle is trying to move along this path. That is, its net velocity will be directed along this path, along the tangent of the curve. So we may write one more point, direction of the particle is along the tangent of the curve. Direction of particle is along the tangent of the curve. First point we got, how can you find out the direction? The direction is very simple that you can make out. It's along the tangent of the curve that we have drawn while showing how the particle is moving in space. Second thing, same will be the direction of velocity. Just now I told you, the velocity will be directed along this direction. So I'm mentioning this by velocity vector v. Now if I resolve the velocity along the two directions, those will be the components of this velocity. Along x direction we can mention by vx, and along y direction we can mention by vy. So we got that vx is the component of velocity along horizontal direction and vy is the component of velocity along the vertical direction. If we mention this as angle theta, what theta will signify? Theta will give us an idea. Theta will give us an idea about the direction of the particle, how it is moving. You see this diagram and easily you can make out that tan theta is equal to Vy by Vx. That is very clear from the diagram. What we obtain, theta is equal to tan inverse Vy by Vx. Actually, with this theta, we can specify the direction along which the particle is moving in the space. Theta is equal to tan inverse Vy by Vx. Now, how can you give the position at some particular instant of time? That will be given by the coordinates, the x coordinate and y coordinate, that will signify the position of the particle in space. Direction will be given by the angle theta, and that is actually tan inverse Vy by Vx. So let's come to some point. First thing, direction that is actually theta, that will be tan inverse Vy by Vx. First point. X and y are obviously the coordinates of the position coordinates of the particle. Second thing, let's talk about acceleration of the particle, and let us see what is the acceleration of the particle as it moves. Now see, we all know that, we all have learned acceleration is actually rate of change of velocity. Now see, as the particle is moving in a two-dimensional space, it's moving along in a plane, so it will be having x coordinate and y coordinate, and it's having a velocity along horizontal direction and velocity along vertical direction. So acceleration will be also having two components. So acceleration along x-axis, acceleration can be divided into two components. Acceleration along x-axis, that comes out to be, you may check this, I am mentioning this by ax, and we know as acceleration is rate of change of velocity, this can be written as ax is equal to dvx by dt. First thing, we got this. Second thing, acceleration along y-axis, so I am mentioning here acceleration along y-axis. See what will, it is very simple. I know you are all thinking in the right way. The acceleration along y-axis will come out to be dvy upon dt. We got two things, but one thing, don't get confused. If let's say acceleration along ax is somewhere like this, don't get confused that. Please make a correction in your mind. If ax is here, ay is here, and if you think that the net acceleration is somewhere here, that's right, and that this angle is, let's say, phi, don't confuse it with theta that already we have given for the direction. For direction, remember, you have to see what is the angle between Vy and Vx, what is the angle actually between the net velocity and Vx, that is the actual direction of the particle. This is not, do not use this for direction, so do take caution, do not use for direction. So one caution that you need to take for theta signifying the direction, do not take that tan inverse ay by ax will be the direction of the particle while moving in space. This was all about velocity and acceleration. Let's come and understand about the trajectory of the particle. Now you see here, I was saying this is the path followed by the particle. If I use the term trajectory of the particle, so what is trajectory? Trajectory is actually an equation which will give you the relation between x coordinate and y coordinate. So trajectory followed by the particle, trajectory of particle, you can say also an object. Generally we will see this in a better way when I teach you about projectile motion. Before that, let me tell you how are you going to find out trajectory of a particle. Let us say the y coordinate is varying and the x coordinate is also varying. The relation, the equation having relation or showing relation, having relation between y and x is actually the trajectory of particle. Having relation between y and x is trajectory or equation of particle, Okay, so you can find out what trajectory is followed by the particle by finding a relation between x coordinate and y coordinate. So generally how we do it, you will be given x is varying with some relation, y is varying with some relation. Generally it will be given as x is varying with some time, and y is also varying with respect to time. The equation will be provided. Try to eliminate time from one of the equation and try to find a relation between y and x. See, we will understand how to find the direction, how to find the trajectory, how to find the acceleration with one equation, with one example that I'm going to show you just now. Let's come to the example showing the relation between x and y, and let us find the direction of the particle. Let us do an example to understand the concept that we have just done. Let us say a particle is moving in space that is along x direction and y direction such that the x coordinate, or let's say the velocity along the x direction, is given as velocity along x direction is given as Vx is equal to, let's say, 5 meter per second. You may take any value for this example. I am giving Vx equal to 5 meter per second. And let's say the velocity along the vertical direction is dependent on time, and the time dependency is given as velocity along y-axis is given as Vy is equal to, let's say, 3t meter per second, where t is time. Okay, that's very easy. That means that t goes to 0, the velocity along y direction will be 0, and as t increases, the velocity along y direction will increase. Suppose the question is find. The question comes, first one, what is the speed of particle, let us say, at t equals to 5 seconds. So find speed at t equals to 5 seconds. First thing is required. Second, direction at t equals to same, direction at same set of time at t equals to 5 seconds. Third, it has been asked, find the acceleration of particle at t equals to 5 seconds. Find acceleration at t equals to 5 seconds. We can do this at t equals to 5 seconds, find acceleration. Fourth, give the trajectory, or write the equation of particle. Write the equation of particle. Means equation of trajectory of particle, that is the more suitable word. Equation of trajectory of particle. How to find out all these given basic details? First thing, only given thing, that is Vx and Vy, and we have to find out at some different instant of time at t equals to 5 seconds, what is the speed, what is the direction, what is the acceleration, and we have to find the equation of trajectory of particle. One more we can add for us, also find the displacement. You can add find displacement in t equals to 5 seconds. A simple example, you will see that how we can solve for two-dimensional motion. And let us do this basic question. Hope the question is visible to you all. See here. Velocity along x-axis Vx 5 and Vy is 3t, that is only Vx is constant. Vx remains constant, that is constant, and Vy is regularly increasing with time. First thing is speed at t equals to 5 seconds. Now say Vx is 3, that's constant. Now at t equals to 5 seconds, now see Vy we have 3t meter per second. So at t equals to 5 seconds, let us find the value of Vy. Vy will come out to be 3 into 5, that is equal to 15 meter per second. The first thing we got Vy. So we will get a speed. Speed we know that is the magnitude of velocity, that will be equal to Vx whole square plus Vy whole square. Find out this value, you will get 3 whole square plus 15 whole square. Find out this value, see you will get the answer. 3 whole square is 9, 15 whole square is 225, 225 plus 9 you will get 234. So under root 234 meter per second is the speed of the particle at t equals to 5 seconds. Suppose the question even asked what the velocity at t equals to 5 seconds. So we have to specify the magnitude with direction. Here I will tell you one more simple term to represent the standard way of answer, that is if you want velocity. So velocity at t equals to 5 seconds, you can represent with I cap and j cap notation. So this will be simple. You see Vx equal to 3. So here I will write Vx I cap plus Vy j cap. This is the velocity of the particle with proper vector representation. Now you see here Vx is 3 and Vy is 15. So 3 I cap, hope this is visible till here, plus 15 j cap. I believe that you all can see till here. Now after this we are required find the direction at t equals to 5 seconds. Now the direction is already hidden in this information. You all can easily find out the direction, and yes, you have got the right idea which you are thinking. It's tan inverse Vy by Vx, or I will rub this part. Hope you have noted down this. The required information I'm keeping on the board and rest part I'm rubbing so that you can simultaneously see the question and see the answer. Next comes for direction. Just now I told you direction, it's actually tan inverse Vy by Vx, or if I represent this as Vx and this as Vy, the particle will be trying to move along this direction. This is the net velocity, let's say this is theta. So tan theta will be equal to Vy by Vx. Tan theta is equal to Vy by Vx, and from here theta is equal to tan inverse Vy by Vx. So I can write theta is equal to tan inverse Vy by Vx. Substitute the values, you will obtain tan inverse Vy is 15, because 5 into 3 15 divided by 3, it will become tan inverse 5. So this is the direction along which the particle is trying to move. Theta we got as tan inverse 5. Now let's come to the third part, that is acceleration at t equals to 5 seconds. For acceleration, if you see, I'm keeping these two equations as it is and I'm rubbing this part, hope you have noted down. For the acceleration portion, Ax, just now I told you it will be dvx by dt. Now see, since velocity along the x direction is constant, velocity along x direction is constant, so that will be 0, and acceleration along y axis is dvy by dt, and since dvy by dt is 3t, this will be actually equal to 3 meter per square second. So the acceleration is only acting along y axis, and that is given as 3 meter per square second. So we are enough here, we can write acceleration as simply a is equal to 3j cap with proper units. This is the exact representation. Fourth one, equation of trajectory of particle. Most students get confused here how to find out the equation of trajectory. It's not too tough to do it. See here, at any instant of time t, the distance traveled along the x direction. Now see, for any time t, let us find out the distance traveled along the x direction. That will be given as x is equal to vx into t, or to be more specific, I am writing displacement along x axis. Displacement along x axis will be given as x equal to vx into t. The second part, the displacement along y axis, that is what is required, because here you see vy is equal to 3 into t. Now you see, we know that vy is equal to dy by dt. Therefore dy is equal to vy into dt. That's clear. Now I am using this part, dy is equal to vy into dt. So if you want to find out the value of y, so integrate both the sides. Dy is equal to integration of vy into dt from 0 to t. Vy value is given as 3t. So 3t dt, substitute the value of velocity, you will get 3t square by 2. This will come out to be 3 by 2 t square. You can substitute the limit. So this is the value of y and this is the value of x. X equal to vx into t we got. You substitute vx as 3, you will get x equal to 3 into t. We got x, we got y. I am keeping here x. Now here you can see t can be written as x by 3. T can be written as x by 3. Substitute the value of t from this equation in this equation. So you will get y equals to 3 by 2 t square. On substituting the value of t from this to this, you will get 3 by 2 and t square. So x by 3 whole square, or this comes out to be, you can see 3 will cancel out. So x square by 6 will be the result. Y equals to x square by 6 is the answer for this. Yes, this will be the right answer. Y equals to x square by 6. In this way you can calculate how to find out the trajectory of the particle for any instant of time. This is actually the trajectory, the general equation, and actually this is the equation of a parabola also.